now looking at KC7. KC7 is all about polynomial functions. So the first thing we need to do is actually define those things. Our first vocab word is term. And a term is a number, a variable, an O, or the product of numbers and variables. And product is just multiplication. So, for example, it could just be a number, the number 3, right, whatever. Variable, it could be x squared, right? You could have exponents. Or like what it means by the product of numbers and variables is like 4x squared, right? It's really 4 times x squared, and that 4x squared is its own is a whole term as well. Then we have what a polynomial is. And a polynomial is an expression expression is just anything expressed with math, right? Symbols, really. An expression is like a math sentence. So an expression made up addition or subtraction, right? Subtraction is just negative addition, but of terms. Okay, so you've seen polynomials before, maybe you just haven't defined them before. Oh, sorry. Windy. Okay. And a polynomial could be one term, but most often when we're talking about polynomials, we're about more than one. The word poly just means many. Okay. So what we're going to be looking at in this activity, or these notes, is our key features of a polynomial. And we're going to start by looking at 3 key features. The first one we're going to look at is the x-intercept. And an x-intercept is the point where the graph crosses the x-axis. Okay. It's also a point where the y value is 0. Both of those definitions are important for that. Okay, so it's a point where the graph crosses the x-axis and the point where crosses the x-axis and the point where the y value is 0, right? Because if you're on your x-axis, you haven't moved up or down at all, so your y value is going to be 0 there. The relative maximum or minimum. So it's either the highest or lowest, depending on which one you're talking about. Depending on the maximum, it's the highest. Minimum is the lowest. Y value on a certain section of graph. We say a certain section of graph because we limit it in a way. Absolute maximum and minimum, which we're not really ever going to talk about, is like the highest or lowest over the whole graph. Relative max or mins are just like with the surrounding points. So if you have a maximum you're looking for a point on your graph, right, like that looks like that, you'll see something that looks like that. If you have a min, you'll see something that looks like that, right? It'll be the point at the bottom. All right, and finally we have what we call our end behavior, and it's what the y value is doing. At the ends of the graph. And we have very specific notation. It's called limit notation. So we say the limit, and underneath it, we say as x is approaching negative infinity. So negative infinity is on the left side of your graph. So as your graph is going left, then next to it, f of x equals, and then whatever. Okay, so there'd be a point. But there's two ends of our graphs. There's the left side, and then there's the right side. So same pretty much notation. The limit as x approaches infinity of f of x equals, and then whatever that side is. Okay? So your end behavior, you always have two sets of your end behavior. And it really should be written exactly like this. You shouldn't write it any differently ever. People like to move things, write things in weird places. It should take a picture, whatever. It should look exactly like that every single time. It's a specific notation. Okay. All right, so let's look at some examples. Looking at example 1, identifying key features. We're going to start with our x-intercepts. So again, our x-intercepts are where you cross through the x-axis. So here's my x-axis. So I have an x-intercept at -3. I got my y value is 0. That's part of the definition. -2, 0. And 1, 0. Okay, so we got x-intercept are just straight where you cross through there. Maximums, remember maximums look like this. So I see a point right here. It doesn't have, it's not right on a number, so I'm going to round that it's saying is between -3 and -2, so -2.5, 1 is that point. And there's no other points that kind of go like that, right? There's no other hills, as we tend to call them. And then our minimum looks like that. So here we have that. We'll round it to 0, -6. And that's it for that. And then we have our end behavior. So, again, our first part is the limit as x approaches -infinity of f of x equals. So again, -infinity is over here. What's happening on this side of the graph? Well, as I follow my graph, as I go towards the left, it's going down. It's always going down, so we say it's going towards -infinity. Okay, so really this is the left side. Right, that -infinity is the left side. Then what's happening as we go right to the positive infinity, Right? As I go, infinity is over here, so as I follow my graph to the right, I'm going up forever. Right side. All right, let's look at our second example. Looking at our x-intercepts first, it's across this line. I see one here at negative 4, 0. Here at negative 2, 0. Here at 1, 0. And here at 3, 0. Our maximums, right, we do have two, right? I have a hill here. And it's a shape that looks like that. And that is at negative 3, 3. And I have this maximum at 2, 3. Our minimums, the minimum, I only have one down here. We'll say that's at negative 0.5, negative 3.5, right? It's kind of between here and here and between here and here. So I'm just rounding, and that's okay to round if it's not exact. And then our end behavior. As I go to the left, it's going down, so towards negative infinity. As I go to the right, I should change the colors. The lighter green equals light green. As I go this way, it's going down towards negative infinity. Alright, go ahead and turn the page. Example 3 and example 4, you need a graphing calculator for, so we're going to skip those for now. We'll do those in class so that we all have a calculator with us, but we are going to look at example 5 and example 6. Okay, so we're doing the same thing, but now we have a table instead of a graph. And I think the easiest way is just to graph your table. And it doesn't have to be like super pretty. I always like look at where my first x is. It's negative 1, 1, 2, 3, 4, 5. All right. So we start at negative 1, 10, so I'm going to put that up here. And then 0, 4, that seems to be about there. 1, 0, 2, 2, so this was 4. This was 0, so 2 going to be about there. 3, 4, 4, 0, and 5, negative 14. So I'm going to drop all the way down. If you notice, I didn't even put like what my y values were. All I'm really doing is it going up or down? So from 10 to 4 it went down, 0 it went down, 2 it went up, 4 it went up, 0, negative 14, right? So it's just kind of a quick sketch of what that graph would look like. And now we're doing the exact same thing. We're just finding our x-intercepts, right? Maximums, minimums, and end behavior. So x-intercepts are along this line. So I see one at 1, 0, and 4, 0, right? These are pretty easy to spot just from your table too, even if you didn't draw it, right? Again, your y value should be 0. Maximums, right, it's our hills. So there's one here. That's at 3, 4. Right, I can't count up, but I know it's at 3, and I'm just pulling it from this point, right? Then our minimums, there's more than one. This one only has 1, right? It's our value. It's right here. And that's at 1, 0. You'll notice that your x-intercept and your minimum is the same point, and that can happen. And then our end behavior. So we have the limit as x approaches infinity of f of x. Alright, well my left side of my, this is negative infinity. My left side of my graph is going up, so it's going towards positive infinity. What's happening on the right side? It's going down, which is negative infinity. You can also kind of tell from the graph, right, these numbers are going up near the end. These numbers are going down near the end. So sometimes you can tell with that as well. All right, looking at our last one, same thing. We're just going to quickly graph it. -6, -5, -4, -3, -1, 1, 2, 3, 4, 5. So again, it starts with -655. So it's all the way up at the top, let's say. 0, -5, or -5, 0. Then it drops down to -45, so we'll drop down. And then -60, so even more. And -55, so up a little bit. -45, so up a little more. -30, up a little more. -10, up a little more. 0. -5, down a little bit. -15, down a little bit. -70, way down. Okay, so again, all I'm doing is deciding is it going up or down from that point. And then just connecting everything. And at this point, I kind of, whatever. It's just kind of a general form of what that graph looks like. X-intercepts. Again, those are, I think, the easier ones to see. We have -5, 0, and 2, 0. Maximums, again, they look like this. There's one right here. Minimums look like this. There's one right here. That is -6, -5, -4, -3. Alright, so it's -3, -60. Then our end behavior. As x approaches negative infinity of f of x equals. Left side's going up. Then we have to do our other side for our end behavior. Right side's going down. Infinity. Alright, and that is it. I'll see you guys tomorrow.